Hello everyone. In this video I will be explaining what the OSI model is all about. Let's dive in. OSI stands for Open Systems Interconnection. The OSI model was created by the Organization for Standardization, also known as ISO. Their goal as an organization is to create blueprints, known as standards, that specify the best way of doing something. The idea behind this is that when all companies and governments follow the same blueprint when creating a service or a product, it ensures safety, efficiency, and high quality. ISO started working on the OSI model in the late 1970s. And officially published the OSI model in 1984. The OSI model is a reference model with the purpose of delivering a standardized blueprint that guides engineers and developers on how to develop network technology correctly in order to ensure communication compatibility across network devices from various different vendors. I will repeat this once again. ISO designed the OSI reference model to make sure that all engineers and developers around the world are creating network equipment, computers, and software that are able to communicate with each other regardless of the brand. In the late 1970s and early 1980s, the computing world was a mess of proprietary network protocols. Today, this era is known as the protocol wars. For example, if you bought a network device from IBM, it wouldn't talk to a network device from HP. The reason behind this was because each technology company had its own unique proprietary protocol that only their devices used to communicate with each other. For those who don't know, a network protocol is a set of rules and guidelines that computers and network devices use to communicate with each other. In order for two different computers to communicate with each other, it's very important that they are communicating via the same protocol. Otherwise, the connection will fail. During the 70s and early 80s, there were no universal protocols used by multiple technology companies as it does today in the modern time. Many tech giants during this era, like IBM, DEC, and Xerox, wanted their own protocol to dominate the industry. That's why this era is called the Protocol Wars. The way ISO attempted to solve this problem was to create the OSI model. The OSI model ensured that technology vendors from all over the world would strictly follow the OSI guidelines in order to make sure their computers were able to communicate with computers produced by other technology vendors as well. Long story short, the OSI model idea that everyone should create network devices by following a universal blueprint to ensure compatibility was a success. However, the specific network protocols that the OSI model was pushing were not successful at all, as they never became widely used. During the same era, the US Defense Department created their own blueprint model called the TCP/IP model, with the same principle and philosophy as the OSI model, but with a slightly different layer structure and with a different set of network protocols. During this time, the US Defense Department were the ones who controlled the world's biggest computer network at the time, called ARPANET. On the 1st of January 1983, the US Defense Department decided to switch the protocol of ARPANET from the old NCP protocol to their new TCP/IP protocol suite that they had recently created at the time. This event is what put an end on the protocol war, because the newly implemented TCP/IP network protocol was not only efficient at handling computer communications across the globe, but also it had its own blueprint and guidelines available to the public, making it very easy for companies around the world to follow along when they're creating their own new technology. Suddenly, plenty of TCP/IP compatible network devices and computers from all different kinds of companies became available in the market. And yes, regardless of the computer brand, they were able to communicate with each other thanks to the TCP/IP protocol suite. That's the end of the story known as the protocol wars. The OSI model failed at implementing its own network protocol suite as a solution to the 70s and 80s era protocol war. However, it succeeded very well as a reference model to describe network communication. Apart from ensuring compatibility across different devices and protocols, the OSI model is commonly used today by IT professionals to precisely describe different things within a network. IT professionals today are using the OSI model terminology to describe things such as describing technical issues within a network during a troubleshooting procedure. Also, describing newly found artifacts within a network during a network security procedure. The OSI model is also commonly taught in school to help students to become better at understanding how network communications work. Now let's talk about the actual content of the OSI model. The OSI model is divided into 7 layers. Each layer represents a unique category of network functionality and communication. The OSI model consists of these 7 layers. Layer 1, the physical layer. Layer 2, the data link layer. Layer 3, the network layer. Layer 4, the transport layer. Layer 5, the session layer. Layer 6, the presentation layer. Layer 7, the application layer. The first layer of the OSI model is called the physical layer. The physical layer describes the physical and tangible components of a network. The main task of this layer is to transmit signals consisting of raw, unstructured data from one device to another device. When I say raw, unstructured data, I'm talking about sequences of ones and zeros getting transported from point A to point B. The physical layer covers the electrical and physical procedures between linked devices. Some good examples of components that are involved in the physical layer are network cables, network cards, and network switches. If you ever would hear a network technician saying, "There's an ongoing layer 1 issue in the network," you would know that the issue is certainly caused by a network component such as a cable failing to deliver signals from point A to point B. Let's move on to layer 2. Layer 2, the data link layer. The data link layer is mainly responsible for making sure every device within a network has a unique identification address called a MAC address. MAC address stands for Media Access Control Address and is used for identification purposes within a network. MAC addresses ensures data always gets transferred to the correct destination efficiently. When delivering data, the data link layer will organize the data into chunks called frames. These frames will later get checked for errors upon delivery. Hardware that represents the data link layer are network cards and network adapters. Why, you may ask? Because these are the hardware components where the MAC addresses are assigned to, meaning that all network cards and network adapters have their own unique MAC address engraved inside of them, even when they're not connected to the internet. Network switches are also involved in the data link layer, because switches are using MAC addresses to know exactly which destination to send specific streams of data. Layer 3, the network layer. The network layer is used by routers to ensure that data gets transferred to the correct destination by using IP addresses. IP address means Internet Protocol address. Whenever a device successfully connects to a network, a unique IP address will be assigned to it. IP addresses are used by routers to identify devices from both the local network but also from external networks. Routers are using what's known as public IP addresses to identify devices from external networks, and routers are using what's known as private IP addresses to identify devices from within the local network. Whenever a router or a destination host encounters a problem delivering an IP package, it will use a protocol known as ICMP, which means Internet Control Message Protocol, to send an error message back to the source host. Layer 4, the transport layer. The transport layer is responsible for transporting data from one device to another device using the TCP or UDP protocol. TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. Both TCP and UDP are network protocols used for transporting data in a correct format. The difference between these two protocols is that TCP is used for delivering reliable and stable connections between two devices, and UDP is used for delivering high-speed connections between two devices. The way an application decides to use TCP or UDP depends on whether it desires reliability or speed. If the main application feature is to send emails, for loading up web pages, or to upload files to the cloud, TCP will be used because reliability is the most prioritized factor in these scenarios. On the other hand, during online video calls, live streaming events, and online gaming, speed is usually the highest priority. Therefore, these services very often rely on UDP connections. Layer 5, the session layer. After a connection has been established by the transport layer, the session layer will now ensure a session gets established between the two devices. Then you might ask yourself, what's the difference between a connection and a session between two devices? When a connection establishes, this means that two devices have successfully gotten in contact via TCP or UDP protocol. This means that the two devices have noticed each other and have the ability to communicate, but nothing else. A session gets established after a connection and can be seen as an agreement between the two endpoints on exactly what type of data should be passed back and forth via their established session. During an active session, the session layer has the ability to restart and to terminate the session. Layer 6, the presentation layer. The presentation layer is responsible for preparing the data received from a session and making it ready for us humans to view it the way we expect it to. For example, every time you visit google.com, Google's servers will send your device a bunch of HTML code. The presentation layer will gather this HTML code and prepare it visually for you, so that the Google front-end page will appear as usual on your screen. Tasks involved in the presentation layer are translating code syntax into human understandable output, decrypting strings into human readable content. It's capable of encrypting data as well, decompressing and compressing file archives into the desired file structure. After the data is fully decrypted and ready to go by the presentation layer, the data will get sent to the application layer right before it gets presented to the user. A good example of a scenario that showcases the encrypting and decrypting process of the presentation layer is every time you visit a web page that is using SSL encryption. The presentation layer will then decrypt all of the website content before sending it to the application layer. Layer 7, the application layer. The application layer is used by different application protocols, such as HTTPS, SFTP, and SMTP. These application protocols maintains the possibility for users to be able to use their applications for doing things such as browsing the web via HTTPS, uploading files to the cloud via SFTP, sending emails via SMTP. In other words, the application layer grants access for applications to interact with different networks by keeping necessary application protocols available. I will now do a quick recap where I briefly summarize the important points of each layer in the OSI model. Layer 1, the physical layer, describes the electrical, mechanical, and physical components of the network hardware, including cables, connectors, and radio signals. Its main job is to transmit raw streams of bits, which means sending signals of ones and zeros from one device to another device. Layer 2, the data link layer, handles delivering data from one device to another on the same local network by packaging data into frames and using MAC addresses for identification purposes. The layer also performs error detection to see if the data was corrupted during delivery to its destination host. Layer 3, the network layer, is used by routers for managing IP addresses and sending data packets across different networks. The network layer is using the ICMP protocol for sending error messages upon error detection. Layer 4, the transport layer, is responsible for establishing reliable and high-speed end-to-end connections between two hosts. This layer uses TCP for guaranteed results and stability, or UDP for fast delivery time. Layer 5, the session layer, establishes, manages, and terminates sessions between two hosts. Sessions can be described as arranged meetings or dialogues that both hosts have agreed upon. Layer 6, the presentation layer, acts as the translator, responsible for data encryption, decryption, compression, and decompression. The role of Layer 6 is to ensure data is in a readable and secure format for the application layer. Layer 7, the application layer, provides network services directly to the user's application. An application such as a web browser or an email client. This layer supports and maintains protocols like HTTP, FTP, and SMTP that applications use to access networks. Thank you very much for watching this video. I really hope you enjoyed it.